Okay, so moving on to question 7 of test 2 part 2. A 15-kilogram block is on a ramp which is inclined at 20 degrees above the horizontal. It is connected by a string to a 19-kilogram mass which hangs over the edge of the ramp. Assuming that a frictional forces may be neglected, what is the magnitude of the acceleration of the 19-kilogram block? So they want to find the acceleration for the 19-kilogram block. So as always, just draw out your forces or your free body diagram. So we have tension on this block and we have weight. On the 15-kilogram block, we have tension. Since it's on a slope, we also have the weight perpendicular to gravity. We also have, because it's on a 20-degree slope, we also have mg is cosine theta. Affecting it is also mg sine of theta. And we have the natural force, opposite of mg cosine theta. So it's saying, assuming that frictional forces may be neglected. So there's no frictional force. All right, so let's just draw out all the summation of the forces. So for in our y direction, all we have to worry about is t minus mg. We know that mass and acceleration is going to be negative because the one acceleration is coming down. Equals t minus mg. So our tension is going to be minus me plus mg. For in our x direction, we have tension minus mg, no cosine, mg sine of theta. So there's no frictional forces, no nothing. Okay. Let me see. G sine. Okay. So we have tension. I want to make sure that I have it. Tension. All right, cool. Okay, so let's go and ma equals t minus mg sine theta. Tension is a plus mg sine theta. Sorry about that. Okay, so let's continue with right. Let's continue to solve for our y. Not our y, I'm sorry, but for our x. So we know our x is going to be tension is going to be mass a plus mg sine theta. Our mass is 15. Our acceleration is just a plus 15, 9.8 of sine of 20 degrees. So our tension here is 15a plus 15 times 9.8 sine of 20 comes to 50.28. All right, so we got a tension for the x coordinate or the x direction. Now let's equal this tension to the y. So our y is this tension. So our tension, we're going to equal it to 15. Oh, not my favorite. So 15a plus 50.28 equals minus ma plus m of g. So equals 19a plus 19, 9.8. This becomes 19a plus 19 times 9.8, 186.2 equals 15a plus 15. Let's put it 3. Okay. So if we move our 19 to the left, this cancels out. 15 plus 19 becomes 34a. And if we move this 50.3, this cancels out, and we're left off 86.2 minus 50.3, 135.9. When we divide 34 from both sides, our acceleration becomes 135 divided by 3.99. We go round off to leave it as 4.0 meters second square. So our final answer is 4, which corresponds to 8.